All right. So what ones would you guys like to look at? Or we could start at the beginning and get as far as we can. Yeah. You want to start there? Okay. Let's do that. We also have tomorrow for review. Based on some of the feedback that I've been getting, I think tomorrow we're going to start off with like a quick practice with conditional and compound when they have the given that, when they say what's this and this. We'll do some quick practice with that, and then I'll take more questions that you guys have. All right. Number one, Dwayne has collected data on the number of occupants of cars traveling on the road past his house for the past week. Based on his data, he has constructed a probability model for the number of occupants of a randomly selected car on his street. Which of the following could be his model? So a probability model, what do you know about probabilities? If I have all of the probabilities for a given event, it has to add to 1. So all probabilities sum to 1. Oh, goodness, sorry. Sorry. Hopefully it won't do that thing again where it zooms in super close. So I want to look through these. Grab your calculator if you need to. If I add up just the probabilities here, because that other side is number of people in the car. I want to add up these probabilities. So if I do 0.6 plus 0.2 plus 0.2 plus 0.1 plus 0.05, 1.15, could this be a probability model? No. Adds up to more than 1. When I look at option B, these probabilities here, when I take them all and I add them, 0.5 plus 0.25 plus 0.15 plus 0.06 plus 0.04. That adds to 1. Before I make my final decision, we got to read all the options and then go and find the best one that answers. Will this sum to 1? No, that adds to 3.6. Definitely not this one then. Oh, they gave me fractions. 1/2 plus 1/4 plus 1/4. That's 1. So this is bigger than 1, right? This is actually going to come out to be 1.25. What about this last one? Will this add to 1? Is it bigger than 1? It's less. 5, 6, 7, 8. This adds to 0.9, which is not equal to 1. It has to be equal to 1 in order for it to be a probability model. So correct choice, B. Number 2, a die is loaded so that the number 6 comes up 3 times as often as any other number. When you initially think of a die, D&D players don't answer. When you initially think of a die, how many sides do you think of? 6 sides on a standard die that's going to come with most games, right? And what are those sides numbered? 1 through 6. 1, 2, 3, 4, 5, 6. This is a standard die. They said that the number 6 comes up 3 times as often. So how many times would it have to show up compared to these others? The number 1, there's only one way that can happen, right? So only one side has a 1 on it. Go away. 2 only shows up once, right? 3 only shows up once. 4 shows up once. 6 is supposed to come up 3 times as often. So how many sides on my die would have to have a 6 on it then? 3. I would have to have 3 sides that are a 6. This way, this only happens 1 out of whatever. This happens 1 out of whatever. But this outcome could happen 3 times out of whatever. If I have a die with these sides, seriously, stop. Go away. Whatever. How many sides does my dice have? This would have to be an 8-sided die. So I want to think about these probabilities before we write anything else down. What's the probability that you roll a 1 on this die that we've just described? 1 out of 8. What's the probability that you roll a 2? 1 out of 8. The probability that you roll a 3? 1 out of 8. A 4? 1 out of 8. A 5. And a 6. Is this 3 times as much as all the other numbers? Yes. So if it tells me about a die or a spinner and something happens that many more times, I'm just going to have that many more sides. So like it's 3 sides if it's 3 times as often. And then from there, I'll figure out how many sides my die must have. What do they ask me to find the probability of here? Rolling a 1 or a 6. So what would be considered favorable outcomes? Which from this list do I want to look at? Which are my favorable outcomes? Yeah, this guy right here. And this guy right here. Are these mutually exclusive events? Yes. There is no way I can roll a 1 and a 6 at the same time. Mutually exclusive means there's no way that both can occur at the same time. You guys would agree with that? Okay. Since they are mutually exclusive events, what would be the probability of rolling a 1 or a 6? 4 out of 8. Because I'm going to take 1/8 plus 3/8. Add them together, we get 4/8. 4/8 is not on that list. 1/2. So this is the correct answer. Because this is the same as 4/8. So far, so good? All right. Number 3, you draw 2 marbles at random from a jar that has 20 red marbles and 30 black marbles without replacement. What is the probability that both marbles are red? I'm going to draw a tree diagram over here to help me understand what's going on. So when I first pull a marble out of the jar, there's a chance that I pull a red marble, or there's the chance that I pull a black marble. Correct? What's the chance that the first marble I draw is red? 20 out of 50. Sorry, I need to make my pen smaller for this. So 20 out of 50 that I pull red. So what's the probability that I pull black? 30 out of 50. Remember my tree diagrams. Oh, sorry, it's going all over the place, but this is the only way that I can think of that I can show this without it being super tiny on the screen. 20 out of 50, 30 out of 50. My tree diagram should show me all the possibilities. When I go to do another set of branches, this is the conditional probability now. So this is saying, assuming I picked red the first time, what could potentially happen now? We said we're going to reach into the jar and grab another marble, right? What are the options for colors when I reach in a second time? Red and black. Do I still have a 20 out of 50 chance of pulling a red marble? Why not? We didn't replace it. So assuming that I picked a red marble, given that I picked a red marble the first time, because that's the branch I'm on, what's the chance I pick a red again? 19 out of 49. What's the chance that the second time I reach in and I actually grab black? 30 out of 49. Because remember, we're assuming that we picked red the first time. If I picked a black marble the first time and I reach into that jar again, what are the options for things that I could select? Red and black again. If I picked a black marble the first time, when I reach in the second time, what's the chance I get red the second time? 20 out of 49. What's the chance that the second time I reach in, I get black again? 29 out of 49. Sorry, my handwriting is super messy there. All right, so I've got my tree diagram way down here in the corner. Which of these would I follow if I want to figure out the probability that both marbles are red? Which branch should I follow? Top one, right? So this would be red and red. How do I find the probability that both of these events happen, that it's red and red? Multiply. So I'm going to multiply 20 over 50 with 19 over 49. You're going to need to pop that into your calculator to see what you get. And then we will know which of these answers is correct. I know it has to be 0 point something because it's a probability. So it has to be less than 1. What'd you get? 1551. So option A is our correct choice here. Whenever they're talking about performing an action or like one event, like it can either be this event or this event, and then we're going to do something after that, and I want to know the probability that both of those things happened, tree diagrams are really helpful. And then you'll multiply along those branches for what we're looking for. Does that make sense? You say what? Whenever they present, like I'm going to make this choice and then I'm going to make some other choice. In this case, we're reaching into the jar and then we're going to reach into the jar again. Or I ask you a question about your political affiliation, and after I get that information from you, then I ask you, like, what grade are you in school? So it's when we've got more than one thing going on. If it's just one thing, we're looking at basic probabilities. Does that make sense? Okay. Number 4, event A occurs with probability 0.2. Event B occurs with probability 0.8. If A and B are disjoint, they are mutually exclusive. We're going to try to figure out which of these options makes the most sense. What does mutually exclusive mean? Can't happen at the same time. So if I'm thinking about a Venn diagram, if I just go look up a picture of a Venn diagram on the computer, it gives me a picture kind of like this. If they're mutually exclusive, what do you know has to be the case about that picture? There is nothing in the overlap here. If they are mutually exclusive, there is nothing in the overlap. If I have event A here and event B here, what can I fill in? 0.2 would go where? A. 0.8 is going to go over here. Which of these options would be true then? I'm sorry, which one did you say? Option A or B. Because remember, and is the football in my picture here. So if they are mutually exclusive, remember when we're talking about or, it's the Starbucks or. Do you want cream or sugar? We could choose both. So whenever you see the and, that's this spot here. So that's why it is not this option. It is going to be option A here. A or B. You could also see it written with that union because we're going to put those together. That's the same thing as or. I want to keep stressing this notation, even though I don't expect you guys to use it. That is what is given on the formula sheet that they allow you to use on the exam. So I want to make sure that you're familiar with that notation. What would have to go outside of these circles here? 0. Why 0? The probabilities add up to 1. Just adding the 0.8 and the 0.2 adds up to 1. So that means there's nothing out here. Does that make sense on that one? Yeah. Okay. Question number 5. If A is 0.24 and B is 0.52, and A and B are independent, what is the probability of A or B? What they are asking me to find here, probability of A or B. If I'm thinking about that Venn diagram, they want all of this. That is A or B. That is A union B. All right, so I want to think through this. What do we know about A and B? I have 0.24 for A, and I have 0.52 for B. What other information did they give me? A and B are independent. How can I make use of that information? Because they didn't tell me anything about mutually exclusive, so I don't know that this is 0 right here. Doesn't mean that they have to be the same. It means that the probability of one happening has no effect on the probability of the other one happening. That means if I know event A happened, the chance of B is still 0.52. If I know for sure that A did not happen, the chance of B is still 0.52. Whether A happens or not, the probability of B is still going to be 0.52. Is it possible that both of these things can happen? Yes. If it's possible that they both happen, then they are not mutually exclusive. They're not disjoint. I want to take what we just said and write it down. We said that the probability of B does not change even if A occurred, right? Does anybody remember how we calculate this? We divide. What do we divide to calculate that? The probability of B and A. Oh, come on. Sorry, guys, I have to fight with my new technology for a minute. All right, it's going to be a jerk. Just hang with me for a moment. Oh my goodness. All right, this guy right here, what in the world? This is the probability of B and A divided by what? Which one came second? In this case, probability of A came second. It's whatever comes after that line. That's my denominator. So the probability of A. I'm going to extend this idea out just a little bit and write what I've got going on here. So we're saying that the probability of B for this, if I had A here, then it would be AB here. But we could do it either way. Yeah, you're right. We could look at probability of B is equal to the probability of A, or the probability of B if A happens. Or we could say it's equal to the probability of A is equal to the probability of A if B happens. If they're independent, this should be the case. So this is, come on, probability of B and A over the probability of A. Which pieces of this do I know? I know the probability of B, I know the probability of A. So do I have the opportunity to figure out the chance that they both happened? Yes, I have all the information that I need. The probability that B occurred is 0.52. Do we know the chance that they both happened? Nope, they didn't give me that. So I just have to leave that one as the probability of B and A. Do I know the probability of A? 0.24. How do I figure out what that numerator is? Multiply what? On both sides. 0.24, because that'll make my denominator cancel here. But if you do it to one side, you got to do it to the other side. Grab your calculator so that you can tell me what that is. Said 0.1248. Why do I care about even finding that piece? What did we just figure out? Like, reference this picture for me.
The middle.
I just found the middle. I just found that overlap part, which I need because I can't just add these two together if they can both happen at the same time, because then I'm double counting some pieces. Do you remember when we talked about that? So how do I figure out what it would be if I added these two circles together, but I'm afraid of that double count? Add them together, subtract this out, because this is the part that I would be double counting. So whenever I want to find the union, the probability of A or B is equal to the probability of A plus the probability of B minus the probability that they both happened, A and B. You guys have told me before that the probability of A is 0.24. What's the probability of B? 0.52, but then we have to subtract out what we've double counted. That's what we calculated over here, and we had the ability to calculate it because they told us it was independent. If we didn't have that information, I couldn't go any further in this problem. I wouldn't have enough to go off of. So I'm going to subtract out that 0.1248. What does that give me? $0.6352. This guy right here. So far, so good? Where did I lose people on that one? Because I feel like that one got kind of deep into the actual, like, here's what I know, here's how I know, computation formulas. I'm afraid I lost some people in there. If I didn't lose anybody, I'm going to go ahead and scoot on. If you think of questions, please speak up. I want to make sure that I'm clarifying anywhere we're getting confused. Number 6, if you buy one lottery ticket in the provincial lottery, then the probability that you win a prize is 0.11. Pretty small chances. Although for a lottery, I got to say that's actually pretty good. Given the nature of lotteries, the probability of winning is independent from month to month, which means if I didn't lose last month, my chances did not change when I play the next month. It doesn't matter if I play over and over and over and over and over again, my chances every time are 0.11 of winning. You buy one ticket each month for 5 months. What's the probability that you lose all 5 months? I know the probability of winning, right? So what's the probability that I lose? 0.89, because it's going to be 1 minus the probability that I win. And they told us up above that the probability of winning is 0.11. So I've got a 0.89 chance of losing every single time I play. I'm not going to circle that. That's not my final answer. That's the probability that I lose 1 month. What's the probability that I lose again the next month? 0.89. Does it matter whether I won the month before or not? What's the probability that I lose the month after that? 0.89. Month after that? 0.89. When I'm thinking about those tree diagrams, just because my probabilities don't change doesn't mean I wouldn't still follow that branch and multiply those probabilities. 0.89, not times 5, to the 5th power. Yeah, because it's 0.89, 0.89 for each month here. One, 2, 3, 4, 5, or 0.89 to the 5th power. What is that when I take it to the 5th power? 0.558 or 0.5584. I'm going to go ahead and write that last number down just in case. As long as you take it out to 3 decimal places, that is sufficient on any test, including the AP exam. This is the probability of 5 losses in a row. What's the probability that you didn't lose all 5 months, that at least on one of those months you won. We could. This is one that we actually learned, and this one we don't need to write all of the options out, because the chance that I didn't lose them all, well, here's the chance that I did lose them all, right? What's the chance that I didn't lose them all? 1 minus this. If they said, what's the probability that you won at least 2? Then I would have to write out all of those options. But on this one, if they say at least 1, and I figure out the probability that I lost them all, it's just going to be 1 minus this chance right here. So at least 1 is 1 minus the probability of 5 losses. In a row. So 1 minus 0.5584, which would give us what? Yes. Come on. Oh my goodness. I don't like my new program because I haven't had time to learn how to use it yet. Whatever. You said it's 0.4416. I don't even have room to write it there. So that would be my final answer for part B, 0.4416. We finished a page, yay. Let's go look at this table on the next page. You select one musician from the group at random. What's the probability that he or she plays a woodwind? What'd you say? 14 out of 88, yes. Here's all my woodwinds. Here's my grand total. 14 out of 88. Pop that into your calculator. Zero point what? $159. So option C. Part 8, you select one musician from this group at random. Given that the person is a male, what is the probability that they play a woodwind? 8 out of what? 14. Not out of 14. 44. The thing that they gave me was that they are male. So I am only looking at the males. All of the numbers have to come from right here. So 8 out of 44. So this is the probability of a woodwind given that they were male. 8 out of 44. Which is what as a decimal? 0. You said 182? Which is option D. Those two questions just set us up for the next one. plays a woodwind and male. I want to know if those are mutually exclusive. I want to know if those are independent. How do I know if they are mutually exclusive? Yes. Mutually exclusive means cannot both happen at the same time. Is that true about this? Why not? They can happen at the same time. Can you be a male and play a woodwind? According to this table, can you be a male and play a woodwind? How many people fit that category? 8. Not mutually exclusive. So any of these options down here that say that they are mutually exclusive, nope. Nope. And even part E, it says we do not have enough information to determine if they are mutually exclusive. Yes, we do. We have that table. So now what's the only thing I need to figure out? If they are independent or not. How do I know if events are independent? Up here, we had the probability of playing a woodwind. That's 0.59. If they're independent, does it matter whether you're a boy or a girl? It should still be 0.159, right? If you're a male, are your chances still 0.159? What were the chances if you're a male? 0.182. Are these independent? No. They are not independent. I put that on the wrong one. So option D, not mutually exclusive, nor are they independent. Because the probability of playing a woodwind was not the same as, was not equal to the probability of playing a woodwind if you're a male. According to this, males have a greater chance of playing a woodwind instrument than females do. So far, so good? Let's do the next question 10 because it uses this table, and then we'll stop for today. What's the probability of selecting a student who is either female or plays the strings? So I'm going to go back and look at that table. Let's just look at female. What's the probability that anybody in this orchestra is female? Probability that somebody is female. 44 out of 88. Half of the orchestra is female. So 44 out of 88. I know for an or I'm going to be adding, but what else do I have to watch out for with an or? Double counting. So I'm going to add something, but then I'm going to need to subtract something. I'm going to have to subtract if they meet both categories. I wanted to know female or plays the strings. What proportion of people in this orchestra play strings? Out of 61 out of 88. How many people fit in both categories? How many people did we double count? 37 out of 88. Because we counted these 37 strings players here, and we counted these 37 females again right here, because they were included in both the row and the column. What do I get when I add all that up? 68 out of 88. Or if I change that into its decimal form, that's going to be 0.7727. I would accept either one of those as correct. If you want to leave it in fraction form because they all have the same denominator, that is totally fine. If you want to put it into your calculator because you absolutely hate fractions, that is also fine. What would my probability notation look like for this? Probability female union, because that's my or where I'm putting together, and then strings.
You don't have that point on the test?
It depends. If it asks for correct probability notation and you don't include it, then yes. If it doesn't ask, like this question did not ask, so I'm only looking for that over there. But what I would look for to see if you understand it, I would have to see this work. Guys, especially on these tests, you have to show me your work. Even if you're just doing it on your calculator, show me where you're getting the numbers from that give you your final answer. Even if that just means that you circle some stuff on the table. That would be enough to indicate where you're getting your numbers from, right? Quick vote on opinion. Tomorrow, do you guys want to keep going through the review? Okay. Do you want me to have some other example problems on deck for conditional probability, for ands and ors? Okay, absolutely. I will make sure that I have that for you and ready.